Alright, so we're in we're still in chapter 7. We're now in section 7.1, and now the video is B, and we're going to talk about simplifying a rational expression. So we're going to simplify a rational expression, and we're going to fast forward through the information that we've already seen. So we've seen this, and this is 7.1a, there's 7.1a, here's 7.1a, especially talking about restricted values. Now we're going to come up to the beginning of 7.1b. So we're going to simplify a rational expression. So when we simplify a rational expression, essentially what we're going to do is we're going to have to do a little factoring. So we have to factor some things, just like in rational numbers. So if we take a look at a rational number like 6 over 9, when we factor things, we have to cancel, or I guess we can cancel, factors. So if we're factoring, we can cancel factors. What are factors? Factors multiply together. So we can take a look at 6, redefine 6 as 2 times 3. We can redefine 9 as 3 times 3, and then we can say it's 2 over 3 times 3 over 3, or we can just say that 3 divided by 3 is 1, so that cancels out to give us an answer of 2 over 3. So remember that the factors cancel out. Factors multiply together. Let's take a look at something and say, well, what happens if, we could redefine this as maybe, well, 6 could be 3 plus 3, couldn't it? We sure could say that it is, because it is. 9 could be 3 plus 6. And what I'm doing here in red is showing us what not to do. Because our answer for 6 over 9 should simplify to 2 over 3. If we take a look at 6 over 9 and say, well, 6 is 3 plus 3 and 9 is 3 plus 6, could we maybe cancel out the 3's and get 3 over 6? And then 3 over 6 is 1 over 2, correct? No, that's not correct. So remember that factors cancel out. Factors are things that multiply together. 3's don't cancel over here because they are not factors. So don't do this. So again, here's another example. If we're talking about numbers, don't factor this way because we can only cancel factors. Down here, again, we've got to cancel factors. Factors multiply together. So if we take a look at this, x plus 3 over y plus 3, again, that's a rational expression because x plus 3 is a polynomial. The 3's do not cancel out because there's an addition sign here. They are not factors. Factors multiply together. If this were x times 3 over y times 3, then the 3's could cancel because that's multiplication. But because we're given x plus 3 over y plus 3, the plus 3's don't cancel out. And the simplification for this one is just simply x plus 3 over y plus 3. And essentially that's the answer because the 3's don't cancel out. So make sure that when we're factoring and we cancel out factors because factors multiply together. Keep in mind that what we want to do is kind of make an expression that's simpler. If we're given a rational expression, we're going to try and make something that's simpler. So let's take a look at some of these. Here's our steps to simplify an equation. Step number 1 is factor the numerator and the denominator. Step number 2 is identify the restricted values. In other words, if we're dividing by 0, that's a restricted value, and that's in 7.1a. That's the first video. And we do that before simplifying because if we simplify and we cancel out some factors, then we might miss a restricted value. And then finally we get to cancel. We simplify by canceling out identical expressions in the numerator and the denominator. And just like our previous example, we can cancel out the 3's up here because 2 times 3, these are both factors here. 3 times 3, those are factors here, and we can cancel those out. So in our steps to simplify an equation, we simplify by canceling out expressions in the numerator and the denominator that are factors. So let's go through our steps here and say, well, let's going to factor our step number 1, I guess, is factor the numerator and the denominator. Step number 1, factor the numerator. 2p minus 14, well, we can factor out a common factor, our greatest common factor of 2 times p minus 7. And that's our numerator. Now if we go and we factor our denominator, we say, all right, well, what's our denominator? P squared minus 49. Well, if we recognize that p squared minus 49 is a difference of squares, p squared is a perfect square, 49 is a perfect square, p squared is a perfect square because 2 is even, 49 is a perfect square because it's 7 times 7, and there's a difference between them, then we can factor this as p minus 7 times p plus 7. So there's our factorization of our numerator in red, denominator in green. So we factored the numerator and denominator, and now we go to step number 2, identify restricted values. So restricted values should be when we divide by 0. When do we divide by 0? Well, let's see. Here's our restricted values. Happen when either p minus 7, I guess when the denominator is equal to 0. So if I've got p minus 7 times p plus 7, when is that equal to 0? If we find the values for p that make this equation true statement, then we've got our restricted values. So either p minus 7 equals 0 or p plus 7 equals 0, and then we have a problem. And if we have a problem, then we've got restricted value. So let's solve the mini equations. I've got p equals 7, or subtract 7 on the right side as well. We set up mini equations with these factors. Either that factor is 0 or this factor is 0. And then we solve the mini equations. I've got p equals negative 7. Either p equals 7 or p equals negative 7 become our restricted values. So there's our restricted values. So we've taken a look at step number 2. Step number 3 now says we can go back to our original red and green Christmassy equation and cancel things out. We can cancel out, remember, factors. So let's take a look at the factors that cancel out. 2 times p minus 7. 2 is a factor. P minus 7 is a factor. In our denominator then, in green, we have p minus 7 is a factor because it's multiplied by p plus 7. P plus 7 is a factor. P minus 7 is a factor because these are both multiplied by one another. Now we can just cancel out the factors. What cancels out? P minus 7 divided by p minus 7 is divides to 1, so those factors go away. It can be divided by 0 and factored out. So my answer then is 2 over p plus 7. Sorry, p plus 7 is my answer. So we've simplified by canceling out identical expressions. P minus 7, p plus 7, those are both factors. They cancel out. What's left? 2 over p plus 7, and we know that restricted values are p minus 7, p equals 7, and p equals negative 7. So p equals 7 can't go into our original equation. This value for the variable can't go into the equation either, so we're all done. So those are our steps to simplifying an equation. Let's go take a look at question B and say, if we've got question B, this one's a little bit more straightforward. We can say, well, for this one, what are our, I guess, do we have to factor our numerator and denominator? If we factor our numerator and denominator, our numerator pretty much is factored already. We've got 18 and we've got a to the 4th. We've got 9, we've got a to the 5th, and those are pretty much factored already, so we don't have to really go too far with that one. If we have, I guess now we identify the restricted values. Step number 2 is identify the restricted values. Restricted values happen when the denominator is equal to 0, so when 9a to the 5th equals 0, then we have a problem. If we divide each side by 9, we get a to the 5th equals 0. When does a to the 5th equal 0? Well, when a equals 0. So a equals 0 is a restricted value. We can't have a equals 0, because if we have a equals 0, and that's an a. If a equals 0, then 0 to the 5th power is still 0. 9 times 0 is 0, and we're dividing by 0, and we have a problem. So that's our restricted value. We can't use a equals 0 in our original equation, or our original expression. So now we can go and say, let's simplify with step number 3. Step number 3 says simplify. I've got 18a to the 4th over 9a to the 5th. Now we just simplify. 18 divided by 9 gives us 2. 2 nines up here. I've got a to the 4th over a to the 5th. Let's see. If we go back to chapter, I think it's 5. The rule for this would be a to the 4th divided by a to the 5th is a to the 4 minus 5 equals a to the minus 1 equals 1 over a. So in our answer, a has to be in our denominator. So we have 2 over a to the 1st power, or a, and that's our answer. You can also look at it to say we've got 4 a's here in our numerator, we've got 5 a's multiplied together in our denominator. 4 of those cancel out, we've got 1 left over, just the number 1 in our numerator and 1 a in our denominator, and that's what we have down here. So there's our answer, 2 over a. So here's what I'm going to do, is I'm going to leave this one here a little more challenging as kind of your ticket to get into class. So you're going to show me what you do for this one. Number 1, factor the numerator and denominator. Number 2, identify the restricted values. Number 3, simplify by canceling out the expressions. So you're going to tell me, and actually if you wanted to, show me the steps that you did. the steps that you've done. Start with this. Show me you factored your numerator. Show me you factored your denominator. And remember, oh, by the way, a equals 1 here. So I would recommend using not the AC method, but the trial and error method. So there's our factorization for our numerator, factor our denominator using the trial and error method. Step number 2, show me the restricted values. Step number 3, simplify by canceling out, remember, identical expressions, and remember those have to be factors. Cancel out factors. And then show me what you've got, and then we can get you into class. We'll get you started.